So today we're going to be talking about material functions, and the example I'm going to give is blending two normal maps together. I was having a conversation with somebody today who didn't know a process of doing it in a way that made sure that like nothing was like weird, right? Like you can take two normal maps together and you can additively blend them together. You'll get a result. It's not necessarily a correct result, especially because the blue channel at that point would get additively applied. There's probably some additional things I could take out of my method to make it a little bit more streamlined or whatever, a few less nodes or whatever. But because we're going to be doing it with material functions, it doesn't really matter, especially for my use case, which is generally going to be cinematics, television, film, that kind of thing. I render to file. I generally don't do much in the way of real time. Well, I do real time, but most of the stuff I do is either on the side or for like this client or that client, but most of the time I'm just rendering to file. So the first thing we're going to do is we're going to create a material function, and we're just going to call this MF for material function and nothing else. And we're going to call this normal blend add, I think is appropriate title. I also have a normal lerp that I had made earlier just to kind of have. I can show that at the end if I remember. And so in the material function, you have essentially just any old material editor window, except you have this output result rather than your material inputs like color, metalness, normal map, whatever. That's fine because we're only dealing with a single output. This isn't gonna go into all the different channels. There's specific material functions for that, or we could even use a regular material function, but all that really matters is what we are going to be focusing on, which is going to be a normal map. And the first thing we need to do that is we need a function input. And this function input by default is a vector 3. Now, if you don't know what vectors are or how that pertains to materials or even in Blueprint and that kind of stuff, coordinate systems, this is probably the easiest way I can explain this. So if you hold down 1 on your keyboard and click in the graph, you get a scalar value, also known as a float. Another way of looking at it is like a one-dimensional vector, or as I like to think of it, is just a one vector. All right, if you hold down 2, you get a two-dimensional float. So it's two channels, X and Y, red and green, U and V if you're doing UV coordinates. And that's just one dimension higher, so a 2 vector. Same thing with a 3 vector. Hold down 3 and click. RGB, X, Y, Z, HPB, could be rotation, scale, translation, anything color. Generally, that's described as a color within the material, because 90% of the time that's what you're going to use it for. Probably even higher, not 99.9% of the time. I've used it for coordinates and that kind of stuff too, but and the last one is going to be 4. So you have 1 dimension, 2 dimension, 3 dimension, 4 dimensions. And in terms of color, that's going to be your alpha channel. Theoretically, you could use it as a time value. I don't think the material editor has time as a thing that it does, except for in things like sine wave and that kind of stuff. There is a time node, but it's not like something you'll use all the time. It's basically just a counter, counts up. Allows you to do things like have things blinking on and off with a sine wave, that kind of thing. But that's not really important for what we're doing. And so we have our 3 vector input, and let's just mark that, just visually so that we know what we're talking about here. So 3 vectors, RGB in this case. All right. We're going to give it a name, and we're going to call it normal texture A. All right. Let's just go ahead and make a copy of that. and we're going to call this one normal texture B. All right, so we have 2 normal maps that are going to come in. The other thing we need, let's just paste another one down, is that we need, I want to set an intensity multiplier on each normal map. All right, so we're going to input type. We're going to set that to function scalar, and we're going to change the name to normal intensity A. We're going to copy, paste this. In Unreal Engine, wherever you have the mouse and you click paste, it will put the node, so that's very handy. So we're going to call this normal intensity B. Save that. Now we want to go from a 3 vector down to a 2 vector because we're just going to work with, initially we're just going to work with the red and green channels. All right, so from here, we're going to create a component mask. All right, and so, 2 channels, but we're going to actually split those into 2 separate nodes. So we have our red component mask node, and we're going to have our green, deselect red, select green, and we're going to split it up like that. All right, so let's just go ahead and copy that. Go down here, we're going to paste that. We're basically setting up both textures at the same time as we go. All right, and so now we want to use our intensity multipliers. All right, so what we want to do is we want to create a multiply for each channel. And this is where I think you could probably do the multiplication before you split, but I don't think it makes that big of a difference in the long run, and my brain just likes it this way. I know the results that I get this way, so to each their own. And again, I render to file, so like things happening on tick generally don't affect me that much, and that kind of stuff. So this isn't really gonna affect me horribly either. And so we're just gonna grab our output pin from our scalar value on that one, and we're gonna double click, wait till that line highlights, double click on there, get a reroute node, and just so we have a cleaner line from here as opposed to dragging 2 lines out from here, we just do it that way just to keep things, keep your graph a happy graph by keeping it clean. I'm sure there's probably some kind of limerick or something I could say there, but that's not really what's flowing through my head at the moment. So yeah, and just because I am that way, let's go ahead and straighten these connections, probably like that. Just because I am OCD about that kind of thing. All right, so the next step is that we want to add, this is where we start actually blending the 2 textures together. So we have, we're still, red and green separated, and now we want to mix them down to, so hold down A on the keyboard and click, hold down A on the keyboard and click. And so we want our red channel going back together that way, and our green channel going back together that way. All right, so we're still 2 channel, but now we want to go back to 3 channel. All right, now if you've ever done this in Photoshop or a compositing application where you've split your image into 3 individual red, blue, green channels, usually you see that color per channel, right? So you see, a monochromatic blue, monochromatic green, monochromatic red as the separate channels. Unreal Engine doesn't work that way, right? So once you split these up individually, they become scalar values per channel. So, it's a texture scalar value or texture float or whatever. So, this is essentially one of these, right? And so we can't just add them back together because we'll just get, a brighter color of white, brighter shade of white, because they're just single channel scalar values. All right, so what we need to do is append, right? If we were, if they had their colors inherently in their channels, we could just do adds or whatever, but we wouldn't actually be able to do it like that. And so now we're literally back to just a 2 channel image, if we were to plug that into here, and we had normal maps actually plugged in, we would get essentially the color yellow, red and green together. But because we're creating a normal map, we need to append a second time so that we can get our blue channel. Right? So we're going to drop down scalar value, set it to 1, plug that into the append, and plug that into the output, and we get blue because this is, basically the third channel. So it's essentially, we've taken this and set that to blue. That's why that is that color. If we had, a 1 value into everything, we'd get white. If we just had the red and green, we'd get yellow, etc. And that, that's how you test to make sure that works too. And so we don't need those anymore. Those are just for visual aid guide. And the last thing we need to do is we need to make sure that these inputs appear within the material editor once we drag our material function into another material, that these inputs appear in the correct order, so that when you plug stuff in, you know what you're doing, that kind of thing. So because we're essentially have an array of inputs, we need to tell the node reader within the material editor in which order in the array that each one of these nodes appear, and we do that through our sort priority. Right, so it controls where the input is displayed relative to other inputs. So we're essentially creating a list. Right, so we want it. So since the highest priority is 0, any array, the first entry in an array is always 0. All right, so it's okay that this one is set to 0, but the subsequent ones have to have higher numerical values. So the next one is going to be 1. One after that is going to be 2. And the last one is going to be 3. And so, like I said, the first input in any array is 0. You theoretically could make this 1, 2, 3, 4, but it wouldn't change the order. All it would do is, make you slightly happier that, the first one is 1 versus just, going with the fact that arrays are, they always start in 0. And so that is going to be it for the actual material function. So let's go on over to a material that I'd already created. And this is going to be mblending normal maps _master. The name itself, M stands for material, general organizational principle within Unreal Engine and a lot of other game engines. Is the first entry, the first letter in the name is what the type of asset it is. So, if it's a texture, you'd have a T in front of it. If it's a blueprint, you'd usually put like BP or something like that in front of it. Static mesh could be SM. Skeletal mesh could be like SK or whatever. It all really depends on what you're doing. Similar, if it's a normal map, usually you have an N at the end kind of thing. So T, name, N. It's just the format in which most people, set up their stuff. And so the name itself isn't that important. What is important is that it is an empty default material. So the first thing that we're going to want to do is open up our content drawer, go into our material functions folder, and because I've been doing this a bunch, deselect our texture filter, and we'll just grab in our add. And so this is what I meant by the order of the name. So we have our normal texture A, normal intensity A, normal texture B, normal intensity B. Otherwise, they could come in either whatever order the engine decides. It might be alphabetical. Normally, if I forget to set those values, it's usually each one of these is flipped. So I think it might be like alphabetical by default if something has the same sort order priority. But since we solved that ahead of time, that's not an issue. We're going to plug that into the normal map because this is essentially just a blend for 2 normal maps. It goes into your material normal channel. We get an error, and the error is because we don't have any inputs. We're missing inputs in this function. It has nothing to do the math on. It kind of freaks out, says, hey, I need something, give me something. So we're going to open up here. We're going to go into our starter content and turn on our texture filter, and we're just going to grab this brick texture, And let's just grab this next brick texture. These are just 2 normal maps. And we're going to plug the first one into slot A and the second one into texture slot B. And we're going to give them some room between each other because we also need to have our float value, or aka scalar value, aka 1 vector. You know, again, I think of them as 1 vectors just because you were just talking about orders of dimensions, you know, so it's just a trick I use in my head to remember at its core what it is rather than just calling it a float or just calling it a scalar. And so once we have everything plugged in, obviously it's working because we can see our normal maps. If you look closely at this normal map, it is just a regular, you know, rectangular brick map. It'll take a second for it to load that, but you can see what that looks like here. And we can check out this one here and just start previewing node here, and it's gonna be like rounder bricks, like stone kind of thing. And if I stop that preview and we just go back to the material, you can see where, you know, one, you know, is square here. You can start to see the rounded version come in here. Theoretically, the second normal map could be a more pebbly type texture or cracks in a, you know, cracked texture, or just, you know, some kind of, you know, detail procedural texture map or something like that, noise texture map, that kind of thing. But because we don't really want these bricks lined up with each other, you know, say we want to do as a detail texture or something like that, we need to tile our textures. And so how you do that in Unreal Engine is that you right click and you just type texture coordinate. And so with the texture coordinate node selected, you can see you have U tiling and V tiling. So this operates on what I call a 2 vector, right? So it's 2-dimensional coordinates, like coordinates on a map, you know, latitude, longitude, that kind of thing. In this case, it's U and V for texture coordinates along a UV. We could actually just use that, but I prefer to keep these square in these particular cases where we have square textures apply to stuff that has square UVs. And that just keeps the tiling uniform. We're going to set that to 1 so that it is just 1 by 1. And then we're going to multiply that together, and we are going to plug that into there. Now, just to kind of show you what this does, if I set this to 4, you're going to see that the square bricks are much denser and the more rounder bricks haven't been tiled. We can do copy paste here, plug that into the UV, and we get the same thing, right? So we're basically just, you know, tiled more of our different values. But let's say we're setting up a generic material hierarchy, master material hierarchy. And we want to be able to, using any material instance we want to be able to change these values not only to, you know, at the same time, but, you know, even different from each other. So what we're going to do is convert this one to a parameter, and we're going to call this normal tile A. We're going to copy that text. Hit OK, and let's just go ahead and set the default value to 1 on that. And we're going to convert this one to a parameter, paste that text, set that to B, and also set this value to 1 by default. Now, we also have our normal intensity values here, and we're going to do basically the same thing. We're going to convert that to parameter. Normal A CT. All right. And just copy that text. And we're going to convert that to a parameter. Hit paste. That's A. We're just going to switch that to B. Probably should have the B at the end, but, you know, just make it easier to find. But, you know, for doing it live, folks. All right. So now we have this. It looks gray, but it's actually black. If you kind of zoom out and get more white, you see that the material is black. So let's go ahead and add some color to this. And we're just going to make this a medium gray color. That's 0.5. All right, so this would be like a normal albedo type texture, that kind of thing. You can see, you can see it, once the dynamic exposure thing kicks in, you can kind of see the detail. But in order to get the detail to pop, let's just make this metallic. You can see it's like kind of really shiny. So let's add some specular in there. Set the 1 so it's like really shiny. And then let's do a roughness of something like, I don't know, like 0.3 or something like that. And stick that in there. Okay. So it's a little bit easier to pick out the details, and that's really all that matters. Okay, so let's, once this is done doing its thing, let's bring up the file browser for that, and let's go ahead and make a material instance from that. So this is going to be M, you could probably call that MI, doesn't really matter. Blending, normal map, master, instance. All right, just hit save, so it saves. And let's just go ahead and open that up. And here you see basically an ordered list of our scalar parameters that we have set. All right, we can turn those on so that they're editable. And so at this point, any descendant material instances we have from here will inherit whatever values you set here. All right, so if you want to set your brick texture to tile to 4 like we had before, and maybe we'll set this one to 16 so that it's like more of a detailed texture that we can still see. You see that the blending works pretty well. Both images are clearly discernible from each other. They don't look weird. You don't have any weird like normal artifacting or anything like that. If we want to go extra crazy and say set the tiling on that to like 48, we might have like some kind of stamped brick kind of thing happening here. You could use any type of normal map for this, and that kind of thing, and that's something that we can cover later in another video. But once I start getting more into material instances in a practical use case type of thing. We also have our intensity multipliers. So say we didn't want the regular brick texture to show up, we set that to 0. Say we wanted it really strong, we'll set it to 4. Right? Say we wanted this subtexture to be inverted, we'll set it to like -2. Right? So we've also, through the intensity multiplication, just through how math works, we've inverted our normals. Right? Pretty straightforward, right? And that's how you go about setting up a material function to blend two normal maps additively together in a way that's pretty clean and easy to read. We can go ahead and apply our material instance onto one of these meshes. And we've got the path tracer going, so everything in all its glory. So say we wanted to reset that intensity back to its default. I think the UV on this mesh is a little bit weird because the bricks look a little bit stretched out, but you can correct that by changing the value within the material editor itself, changing that scalar parameter into a 2-channel vector kind of thing. But If you wanted to take one step further, kind of like a little bonus, I talked about having descendant hierarchies. So we can make a child of that instance. Instead of calling an instance, we take master out of that and say, let's say, well, that's sphere, right? So we know we're going to apply this one to that sphere. Let's go ahead and do that. And it doesn't change. And of course it doesn't change because we haven't done anything to modify it from its parent. So we open that up and you can see that its default values are its change values from what we had set in the parent instance, right? Turn this stuff on and we can make further changes. So say we want to set that to 2, have the larger bricks, and we still have the more detailed sub brick texture, that kind of thing. But so let's say we want to make a duplicate of this and put it back on the other mesh. So instead of sphere, I don't know what shape that is, so we'll just call it barrel because it's kind of barrel shaped. All right, and so let's select that mesh, plug that material in there, and just for fun, let's save all that. And so now we have our 2 material instances, but let's go back to our master material. And so we have this color here, and we can convert that to parameter, and we'll just call that color. But also, before I do that, let's just show what happens when I do that. So I've added color. I haven't actually changed the color, but if I go into the master parameter, make that red, hit OK. I've changed that color for both assets. So let's do that again. Let's change the color, hit OK. Both assets have now changed color. So we're now using a parent material instance of the 2 sub material instances to have a broader control over multiple assets using multiple materials. Now, if I want to take the sphere material and I want to change that color, I can set it back to its default value, or I can make it red. All right, all within the same hierarchy, but different from each other. All right, so that's our master material, but so we want to say we change the barrel. So again, we can just override that material, make it kind of yellow. Same difference, and we still have this texture here, and if there's like some sort of change we want to apply to that, we could, that's not overridden, we can still do that. So that's going to be it for this video. Hopefully that was presented in a way that's easy to understand. And I will see you in the next video. Thanks for watching. Bye.